Thank you. Yeah, I have no idea how to pronounce that either. Don't worry about it. Laundering cryptocurrency for fun and retirement. A little bit about me. Assorted handles and groups. Here on behalf of myself, not my employer. Just get that out of the way. I just think cryptocurrency is neat. I'm just a guy. I read some stuff. I'm not that smart. You can probably do this better, and you should do this better. So, what we're going to cover. We're going to talk about typical cryptocurrency transactions. We're going to talk about why why laundering is desirable and necessary if you're planning to steal cryptocurrency. We're going to talk about why laundering and anonymity in transaction history matters beyond theft. And then we're going to talk about some laundering theory and practice. And we're going to talk about zero cash and kind of the future of anonymous transactions. So I guess kind of before I get into this, this assumes kind of a baseline knowledge of cryptocurrency as a thing. I assume all of you can read Wikipedia and kind of figure that out. So let's jump into what cryptocurrency transactions are, actually. You have your set of inputs, you have your set of outputs. Your inputs reference previous outputs. And inputs are just basically an amount, say 1 Bitcoin, and you just want to say, I have an input of 1 Bitcoin, I have an output of 1 Bitcoin. The input is coming from my address, the output is going to my buddy's address, or my address, or whoever's address. And the difference in the amount of the inputs and the outputs is your transaction fee that's paid to the miners to give them an incentive to actually process the transactions. So a typical transaction would look something like this. You have your input, you have your output, you have your amount. And I screenshotted this morning off blockchain.info. So the other piece of this to kind of know is that blockchain.info, and anybody can record this information, kind of does all this neat stuff where they think it came from the UK, it was received at a certain time, the amount, and so on. So transactions in cryptocurrency are amazing, complicated, and you can do way more with them than just send people money. And it's worth reading about, but we're not really going to get into that here. So if you think about the lineage of a transaction, we talked about the inputs and the outputs. You can follow that pathing because those inputs require cryptographic primitives to sign them, essentially. And you can follow those back through a chain of inputs and outputs and see where Bitcoins came from or whatever cryptocurrency. And the other piece is you can watch where you send somebody coins, you can then start watching their addresses in the future and see kind of maybe where they spent their coins, potentially. And so the other piece of this is the fungibility of currency is a very important thing. And fungibility basically just means if Alice mugs Bob and gets $10 in cash, and Alice spends her $10, then the person that she spent the $10 with doesn't know by virtue of looking at the $10 that she stole it, right? It's not an intrinsic property of US currency, paper currency, to remember where it came from. So you have a built-in fungibility to US currency that normal people usually can't kind of unfold. Feds and banks can and do, but that's another piece, whole other talk. So when you get into Bitcoins, if Alice steals 37 million from her darknet market and then tries to send that to an exchange, the exchange can, if somebody says, hey, Alice stole 37 million from all these addresses, the exchange can look at the blockchain and say, no, we don't want to process that. We know it's stolen. We also know where you live. The police are on their way. So that's a problem. So beyond theft, we can think about, going back to the fungibility piece, we can think about the possibility of blacklisting Bitcoins as they flow through the network. Let's say that we know a set of addresses that are used to pay for things that we don't like gambling. Satoshi Dice is a popular thing. So we can actually say we don't want to accept any Bitcoins from known Satoshi Dice addresses, or we want to build a Bitcoin client that doesn't process transactions from Satoshi Dice or other gambling sites or people we don't like or whatever. So that can be either done through legislation or it can be done with devs pushing an ideology, which that last one has actually happened. So there's a fairly well-known dev called Luke Jr. that fairly regularly has been trying to push, and I know you can't read that, these will be online, you can read it later. But basically, he continuously tries to push patches into the Gen 2 version of the Bitcoin client that would blacklist various gambling sites on the basis that they're denial of service attacks. And basically, everybody has called him out on his bullshit multiple times, continuously, but it's something that people are trying to do actively. This is just a short list of the ones that he tried to blacklist. And there's the bug report when people realized what he was doing and said, stop it, and it was resolved, and the patch was not accepted as the default configuration again, too. So what you run into, let's say that that was accepted, let's say that that was accepted in a major distribution, you run into an issue where one Bitcoin is not equal to one Bitcoin, or one Bitcoin is better than another Bitcoin because of its lineage. And that's a problem and undermines the confidence in the system of a given cryptocurrency. So currently, in cryptocurrency systems, fungibility is enforced by an opt-in social contract. Basically, by virtue of using a certain configuration of the software, you agree that Bitcoins are going to be fungible. If you happen to use the modified version that Luke Jr. made, your Bitcoins would not be as fungible as other Bitcoins when you participate in the network. So what I prefer in my systems, especially currency, because it matters a whole lot, is to have fungibility, something like fungibility, something that's that important as fungibility, enforced by mathematics versus enforced by an opt-in social contract. Because mathematics doesn't usually describe to read your email in the interest of national security. So let's get into the actual laundering bit, because that gets kind of heady. So I ripped off my darknet market. How do I not get murdered? Yeah. You can only get murdered once. It's great. So I'm going to talk about a couple of techniques. Various anonymizing networks, coin mixers, and then a little kind of idea that I thought up using altcoin exchanges, which is fairly straightforward, not novel at all. I'm sure somebody else has thought of it before. So using anonymity networks, basically there's no reason not to do it. It's very easy to configure cryptocurrency clients to hook into these. But they don't anonymize your transaction history on the blockchain. They will anonymize your source IP address. If you remember back to the blockchain.info shot of where it picked up the IP address, that IP address that it's picking up is the first place that it saw that transaction hit the network. So that may not be your IP address to begin with, but there's really no reason not to do something like this if you're trying to launder Bitcoin. So all of your clients should be on an anonymity network. So mixers, using CoinJoin, SharedCoin, other implementations of that, they do provide some obfuscation. Basically, the way that these are implemented right now, you're trusting mixing services not to keep logs, you're trusting them not to steal your coins, you're trusting them not to collude with coin owners in the context of theft, which is entire, and they have, exchanges have done kind of that, and I would expect some mixers might in the future. And there have been analysis attempts on the SharedCoin system, which the SharedCoin developers claim that they fixed, where somebody managed to actually start linking together transactions with a very high degree of accuracy in some cases. It required a large amount of computing power, and they weren't really able to, I think they got about 50 to 68% of the transactions with some degree of certainty of linkage following through the SharedCoin mixing process, which if you're worried about getting murdered is not really enough. So a typical shared coin transaction, and what these mixers basically do is, you remember back the previous transaction, we just had one input and one output. So that's arbitrary. We can have as many outputs and inputs as we want, as long as the numbers add up. And only add up in the sense that the inputs have to be greater than the outputs. So essentially, shared coin is run by, shared coin is open source, but blockchain.info runs an implementation of it. And essentially what they're doing is, you can say, I want to mix my coins up. So you push them into their system, and they will combine your coins with many other people's coins, and then send them out to many addresses, and they'll repeat this process many times to intermingle your coins. So currently the system is centralized and in the shared coin implementation, and there have been attacks on this in the past. Coin joined Sudoku was the name of the one that on the system. I did find some writing that, in theory, these mixing systems can be distributed and decentralized in a trustless sense that are resistant to denial of service attacks. And that's basically what G. Maxwell, one of the core Bitcoin devs, was saying. Yeah?
Do those basically just add a bunch of transaction history to the Bitcoin?
Kind of. So basically, they are trying to fuzz up the transaction history so that if you're looking at a transaction log and you have one input and one output, you can say, hey, that guy sent a coin to there. But if you have 100 inputs and 100 outputs, because the inputs and the outputs, they're not linked by anything intrinsically in the transaction. The transaction just has to have more value in terms of Bitcoins and its inputs total than its outputs. So you don't know necessarily which inputs are going to which outputs, and when you add a whole bunch of potentially unrelated inputs to a transaction and their associated outputs, then you get kind of a muddying of the waters effect, essentially. The what? Yeah. Exactly. So, getting into abusing altcoin exchanges, essentially the theory here is that the goal is to break our transaction history. So we can do that because we can manipulate altcoin exchanges or abuse them, I guess, to do that by the virtue of the fact that they keep internal logs of most of their trades. They're not executing trades against the blockchain. They're executing trades against their database, more than likely, maybe. So the idea would be that you would transfer 50 Bitcoins into an altcoin exchange. You would then sell those 50 Bitcoins for all the Dogecoins. You would then sell those for 20 billion Litecoins and then sell those back for 49.5 Bitcoins because of transaction fees and wiggle and so on. So the downsides to this, exchanges keep logs. So basically you're trading logs on the blockchain for logs on an exchange. And for large exchange thefts, or for large thefts, exchanges have been known to essentially blacklist coins or freeze them as they come in. And sometimes these exchanges can require very invasive identity verification. And the volume of coins that you're trying to move could be an issue. You get into, there's only so many coins or so many Litecoins that people are trying to sell, and if you have $38 million worth of Bitcoins, you may end up buying up all the Litecoins, and that causes a very noticeable spike. So pulling those together, basically, in thinking about this, if you're planning a Bitcoin heist, plan the laundering process first. Because the blockchain is forever, so is death. And if you're stealing $38 million, you probably don't want to immediately die after you do it, or you wouldn't be stealing it. So basically combine the previous methods, automate them, and test it. Have scripts that detect when Bitcoins come into a wall. You can interact with Bitcoin D over RPC. You can write Python scripts to talk to it and tell it what to do. So in theory, you could write a Python script that says, when I get coins into this wallet, send them onto this wallet. So let's say the wallet that you send them onto is the coin mixer that you set up. And then when they come out of there, you write a Python script to interact with, most of the coin mixers are basically web applications. So you write a script to interact with a web application to say, when my coin, or send my coins off to this address, which would be at the altcoin exchange. And then you write a script to interact. Most of the altcoin exchanges have APIs for market trading and margin trading and stuff like that. So you write a script that says, when I get coins coming into my altcoin exchange, push them through all these currencies, and then send them back to this other mixer. And basically just loop, rinse, repeat, and try to break your transaction history as much as possible. So, and also test it, make sure it works. Regardless, if you're planning a theft, watch every OPSEC talk you can find. Google OPSEC, put it into YouTube, and watch everything. But the short version is basically, don't take notes on a fucking criminal conspiracy. Think like a defender. Think like the drug dealer that's going to want to kill you after you stole all his money and his boss is trying to kill him. And weigh your risk, right? Is it really worth it to steal $38 million and then worried about being murdered for the rest of your life? So, and you can study mistakes made by other criminals. I actually recently found a nice little piece of justice.gov with essentially all the cases that went to court and got pushed through with pretty detailed descriptions of what the criminals actually did, which was interesting and informative on what not to do. And obviously most of those are related to kind of pedestrian level crime, but still informative. So looking forward, this is kind of an issue, as we're talking about fungibility, it's an issue for cryptocurrency going into the future. Because if we want these currencies to be useful and sustainable as we're going forward, as more and more people know about them, they're going to start getting into these and pushing their ideology on them, and having them be able to function as a currency, which fungibility is part of the definition of something that's considered a currency. This is something that we have to care about and have to figure out. So there are two projects, kind of by the same people, that I found that looked fairly interesting. And so their naming conventions are awful. So Zerocoin is the first project, Zero Cash is the second project, and Zerocoins are referenced inside the Zero Cash project as a different thing than the first one. Anyway, so probably the best way to talk about it is Zerocoin version 1 is a library that can be tacked on to a cryptocurrency as an add-on, essentially. And they've published white papers and code for this. Zero Cash is a full-blown altcoin specification, but they've only published white papers for this as far as I could find. So Zerocoin is essentially a built-in laundry that you can use inside the blockchain without any kind of a centralized trust system. And this is fundamentally different than the shared coin system, and it's fundamentally different than well, and it might actually be what G. Maxwell was kind of thinking about, and he didn't really go into detail. But basically, Zerocoin uses zero-knowledge proofs to mathematically break transaction histories so that you can, this basically takes the form of, you say, I want to buy a Zerocoin. So you send a 1 Bitcoin transaction that says, I want to buy a Zerocoin. You lose your 1 Bitcoin, you get 1 Zerocoin. Then at some point later, you say, I want to cash in my Zerocoin and get my Bitcoin back. So you create another transaction. When you originally created your Zerocoin, you get a serial number. You reveal that serial number. and then you basically push 2 zero-knowledge proofs to the blockchain. Now, zero-knowledge proofs are kind of fascinating because they allow you to make a statement that says, this is totally true and I totally did it, and that's all you have to say. And mathematically, you can prove that the person totally did it, which blows my mind. I don't know how mathematics works. But I would love it if somebody could explain that to me in detail. So there were some problems with this when they first built it. The transaction sizes, based on their protocol specification, were fixed. They just set it arbitrarily at 1 Bitcoin per 1 Zerocoin. So you could cash in 1 Bitcoin at a time and get 1 Zerocoin out. The amounts are visible, and the zero-knowledge proof piece of this required was like 35 kilobytes, which to commit a 35 kilobyte transaction to the blockchain every time somebody buys a Zerocoin is infeasible, essentially. The normal transaction size is in the bytes, hundreds of bytes. So this is not ideal, because if you make a system that is hard to use, essentially, then people that are going to use it are either paranoids like us or criminals like us, I guess. So this is not ideal. So Zero Cash, and kind of the story behind Zero Cash, based on watching some of their talks, is that they presented their Zerocoin specification to a conference, and they kind of laid out the issues that they were having and the size of the proofs. And after the talk was over, a couple of guys came up and said, hey, we have some zero-knowledge proofs that have really small sizes, let's talk. And so Zero Cash happened. So basically, they reworked the underpinnings, and as they were reworking the underpinnings, they realized that they didn't really need to make an add-on for Bitcoin. They decided to just go ahead and make a whole altcoin. Oh, and so the other piece about the Zerocoin library that I forgot to mention is that you could not transfer Zerocoins to somebody else using the blockchain. You could buy a Zerocoin and you could cash out a Zerocoin. All normal transactions were conducted in Bitcoins. So Zero Cash transaction sizes are much smaller. It's faster to validate. They have a 56-page white paper with a whole lot of math in it. Absolutely worth reading. Still reading it, so recommend you do the same because it's fascinating. So the really cool thing is that the transaction source destination and the amount are entirely hidden in this system, and that the miner fees are the only public pieces of the transaction. So this is the first issue that I found with the Zero Cash project. I haven't seen any public posting in terms of related to their project for a good while. It makes me think that it's either abandoned or they ran out of funding or what have you. And they never released any code, which I don't quite understand that.
Just 1 year into their 6-year PhD.
I know, right? They ran out of their European Research Council grant. Which this actually was, this research was funded by the European Research Council, according to them, or partially, in large part. So basically, the technical issues with Zero Cash is that the protocol requires us, being the people that use it, to trust one person exactly once. Because as a feature of the math underlying the protocol, you have to generate this massive key pair. And by massive, I mean the public key is almost a gig. You have to generate this massive key pair, and you have to trust that whoever generated it will delete the private key and then release the public key. So what happens if they don't delete the private key? Basically, they have the ability to create Zerocoins, if arbitrarily, which is a problem for a currency. They do not have the ability to undermine the anonymity, which is good, right? But it would basically break the currency. The other issue, as I was kind of reading through this, and like I said, I'm not a mathematician, I don't know the details behind this, and it might be a trivially solvable problem, but based on what I was reading, so basically when you spend a Zerocoin in this protocol, or when you spend a Zerocoin in the Zero Cash protocol, you destroy that Zerocoin, right? So that's not how Bitcoin works. The only way that Bitcoins can be destroyed is, say, if you lose your wallet, or you send them to an address that doesn't exist, or things along those lines. With Zero Cash and Zerocoins are actually destroyed every time they're spent, and there's a limited number of Zerocoins. So this is kind of an issue. So because you will eventually, in theory, run out. Now, I don't know if this is as simple as just, so they keep track of the Zerocoins using a Merkle tree, which is a giant hash construction. And basically, I don't know if it's just as simple as switching out that Merkle tree for something new, and if that could be built into the protocol. But it seemed kind of like a fundamental issue that would eventually come to a head. So we can probably engineer around these. Buy a computer, have a bunch of people buy it, watch everybody burn the computer when you're done, kind of thing, in theory. Yeah, exactly. Beat it with some bats. And like I was saying, maybe you can just switch out the Merkle tree root and get around that coin amount problem. And it would be awesome if some people that were better at math actually read through that white paper and evaluated what they're trying to do in the constructions that they've made from the perspective of an attacker. Because while these guys are really smart, because they came up with this stuff and they understand what zero knowledge proofs are, they're not pen testers, they're not hackers. They're definitely hackers. They're not pen testers, probably, and it would be good for somebody with the mindset that's trying to break their system fundamentally to have a look at it. Because if you think about it, even people that want to steal Zerocoins, excuse me. Yep. Yeah, I know.
Was that your mom?
Yes. Right? No, it's my alarm for my caffeine pills. But anyway, even the people that are trying to steal Zerocoins, they want those Zerocoins to have value in the future, right? They don't have a fundamental interest in undermining the Zerocoin system, or any cryptocurrency, for that matter. Because if you think about it, I mean, Bitcoin's great in the sense that people are always trying to figure out how to steal them from other people. They're not necessarily thinking about how to undermine the system of Bitcoin, because how would that enrich them in any way? So that's why people like us and security researchers really need to look at these systems, evaluate them, and try to break them fundamentally. Not steal people's coins, but fundamentally destroy the system in such a way that everything would be worthless. Because that's how these systems will eventually potentially fail. So that is, yeah, that's everything. So hope you guys enjoyed it. Any questions?
So if a major theft occurs and the coins manage to make it through the attacker's hands and get back into circulation, have there been normal people losing their value because it's fruit of the poison tree?
That is one thing that I would love to read more about.
Okay.
Because we have had notable Bitcoin thefts in the past. That's basically research I didn't get to yet.
No worries.
So that's definitely worth looking into.
Would you like to speculate as to how the Evo guys are going to make without being murdered?
Right, yeah, I don't know. Because one of the things about this is that as you go further on in time, these techniques like abusing altcoin exchanges and things like that become less effective, potentially, if people get mad that you stole their money. They can put the word out and say, hey, these people stole our money. And altcoin exchanges and other exchanges might start reading those or saw those, and they start blacklisting coins. So the impression that I got in doing this research is that if you're going to launder coins, do it right now. Like, do it as soon as you steal them. So yeah, I don't know. If they haven't started laundering them already, I don't know what their plan is.